All right, in this video, we're going to teach you all about law of cosines. All right, law of cosines. There are kind of three of them, but they all follow the same pattern. All right, so normally you want to use this when, like in this first example that we're going to have, when you have maybe one of each of our three letters, or like we're going to see in our second example, just three sides. Okay, so here I have a capital A, lowercase b, and lowercase c, but none of those letters match up, and there's no way to subtract from 180 with my angles to get a third angle so that I would have two of the same letter. So because of that, that's the reason, or that's when you want to use law of cosines. Now, each of these three are written out, and they're kind of the same, okay? So if you look at what's happening here, let's say we have the a squared first. First off, it starts off like the Pythagorean theorem. A squared equals b squared plus c squared, a little bit. Or I guess it's this one would be the Pythagorean. But either way, that letter that comes first, you're going to take cosine of it at the end. The other two letters, the b and the c, you also subtract 2 times those same letters. So like this one was a squared plus c squared minus 2 times a times c. So if you can kind of figure out that pattern, it doesn't matter whether you need a, b, or c, it's going to be the same kind of pattern there, all right? So anyway, in the one that we have, the one that I want to use is going to be the capital letter of the angle that I have, in this case a. So I'm going to use this top version. So here we have a squared equals b squared plus c squared minus 2bc times the cosine of a. So let me put those missing parts into this equation, the little b, little c, as well as capital A, and watch what happens. All right, so after I got that all filled in there, you'll notice that the only variable that's left is on the left side of our equal sign, which means I can actually type this in exactly like it looks into my calculator, and then since that's what a squared is and I need a itself, I can just take the square root of that. Okay, so I'm just going to put this in exactly like it looks in my calculator on that side of the equal sign. So it's going to be a squared equals, and I'm going to type in 12 squared plus 14 squared minus 2 parentheses 12 parentheses 14 cosine. This is being multiplied here, so just cosine right next to the 14 before it. Cosine of 39.4. All right, close those parentheses and hit enter, and it gives me 80.3615. 80.3615. Now I went out a few more decimal places than usual because I need to take the square root of that, and we want to be as precise as possible here. All right, so a, if I take the square root of both sides, on the left side, the a and the square root cancel, leave me with just a, and then the square root of this, second square root, second answer. It's probably gonna be really close to 9, and it looks like it is. It's 8.96. So we get 8.96, right? The square root of 81 would have been 9. So over here where I have a, I can say that a is 8.96. And then I would encourage you guys again, if you have used law of cosines, and now you have both capital A and lowercase a, you can now use law of sines to find the rest, all right? So for example, remember law of sines says if I have little a, which is that 8.96, over sine of capital A, 39.4, then I can find one of my other missing letters. In this case, my next one would be b. All right, so little b is 12 over sine of big B. All right, and then you just cross multiply and solve for the b here. Let me do that in fast motion for you. All right, so this one is one where we end up with sine of b by itself equals some really, really small number. And so to find b, I have to take the inverse sine, the inverse sine of that same small number. 0.85 is probably good enough in this, but 0.008. Okay, and if I do that, second sine, second answer, this gives me 58.2. Okay, so capital B is 58.2 degrees. And then to find C, I can just take 180 minus those other two, minus 39.4, minus 58.2. And that's going to give me 82.4. 82.4. Always double check to see that your largest angle, which is C, is across from our largest side. And it is. All right, let's try one more. All right, for the second problem, it gives us 3 sides, but no angles. All right, so for this one, it doesn't really matter which of those 3 choices you pick, which one of those law of cosines. I'll probably just use A since it's first alphabetical order. And I have it written out up here for us. Okay, so I'm gonna fill in the A, little B, little C into our law of cosines. And when I do that, you'll notice that the only capital letter here is the A. And so that's what we're gonna solve for here at the end. All right, so let me throw those in real quick for you and then we'll do the math. All right, so I went ahead and put those little A, B, and C's into our formula, and I went ahead and also squared the 12, 17, and 14, and I took -2 times 17 and 14 and got -476 here. Okay, so again, like I said earlier, the variable that we're solving for is capital A, or the angle A, you might say. Now, you got to be a little bit careful here. The temptation is to just kind of want to add these and subtract that together, but if you look at what's happening here, this is going to end up being one term, and so is this. Since it's being multiplied by the cosine of A, you can't just subtract that -476 into this as well. You're going to have to probably move that part over and then eventually divide by -476, okay? So with that said, let's take 289 plus 196, and that gives us 485. So now it's 144 equals 485 minus 476 cosine of A. I always like to put the time signal or time symbol in there for us, just to show that it's going to be one term. Anyway, subtract 485 on both sides. And then when you do this, sometimes my students get a little bit of red flag that pops up, which I'm glad for, but it's okay here that you end up with a negative, all right? Sometimes negatives doesn't seem like it's going to be quite right, as angles can't be negative, but watch what happens. If I take 144 minus 485, this gives me a -341 equals a -476 times cosine of A. So what's going to happen is when we divide this negative, it'll end up being positive again. All right, so if I divide both sides by that 476, now I'm just left with cosine of A over here by itself, and whatever -341 divided by 476 is, and we get, oops, I did it wrong on my calculator. -341 divided by I forgot my -476 is a positive 0.71638. Okay, and you want to go out a few digits with that just so that you can be nice and precise here. Anyway, that's going to equal cosine of A. Now, because it equals cosine of A, remember we have to use inverse trigonometry to solve for that. So we can say the inverse cosine is going to be inverse cosine of 0.71638, or whatever that number was. It should still be in your calculator. That's going to equal A. So again, that number is in my calculator still. So I'm going to say second cosine, second answer for that number. And this gives me 44.2. 44.2, and that is going to equal our angle A. So of course that's in degrees, 44.2 degrees. Right now, once you have done law of cosines and found one of those missing angles, then I would encourage you, if possible, use law of sines to figure out the rest. Okay, it's going to be a little bit easier than all of that. And so in this case, what I have is both of my A's, both capital and lowercase a. And because of that, I can now use law of sines. So I'm going to say little a, which is 12, over sine of capital A, which is 44.2. I'm going to set that equal to my next letter, which is B, which I have little b, 17, over sine of capital B, I don't know. All right, so then I can cross multiply. We've done law of sines before. If you don't remember that, I will throw a video up here for you, or maybe down in the description or something. But anyway, let me cross multiply. We'll find B really quick, and I'll show you a quick way to find C as well. So let me fast forward and do this for you. All right, before I write the answer, this is kind of cool. It was 0.98765, and then it kept going, but that was kind of interesting. Anyway, if we take the inverse sine of that number, we get 80.986. We'll just call that 81 degrees. All right, 81 degrees for capital B over here. 81 degrees. And then to find C, of course, if you have the other two angles, you can just take 180, the number of degrees in a triangle, in any triangle, and subtract 44.2 minus the 81, giving us 54.8, all right? 54.8 for angle C. Now, one way to check yourself to see if you are right or not is look at what your largest angle is. In this case, it's 81. Your largest side should also be that same letter. So 81 was B. Our B over here is yes, 17, which is the biggest of those three sides. Same works for the smallest. All right, so that's a way to check yourself, guys. Anyway, if this helped you out with law of cosines, give me a thumbs up. All right, we'll see you in the next one.